Good morning, friends. In today's session, we are going to work out a problem on an isosceles triangular lamina. Friends, you know very well that an isosceles triangle will have a base AB of some length and it will have a height or altitude, which is the distance measured from here till this corner C. Now, in today's session, friends, we have a problem which states like this. An isosceles triangular lamina of base 30 mm means that this base is 30 mm and altitude 50 millimeter. Altitude means from this AB till this vertical height is called the altitude and it measures 50 mm. Resting on one of its shorter edges on HP, it has the shorter edge AB and AC and BC are the longer edges of this triangular lamina. It appears as an equilateral triangle of side 30 millimeter in the top view. That is to say, when the lamina is resting on HP or on ground to say, this is seen in its true form in the top view and as a line in the front view. Friends, remember, whenever any lamina, irrespective of its shape or size, is placed on HP or parallel to HP, its true shape and size are seen in the top view and it is seen as a line in the front view, irrespective of its orientation with the VP or the wall to say. So friends, he says this appears as an equilateral triangle. You know, by definition, an equilateral triangle will have all the sides equal. AB is equal to BC is equal to CA. This happens when this lamina is slowly lifted above, the corner C is lifted above. This becomes an equilateral triangle of the given side. That is the minimum size of the base. And friends, let us start the problem. And he says the lamina is resting on HP. So what I do, I keep the lamina on HP. My palm is the HP now. And obtain the top and front views of the lamina. In the top view, friends, since it is on HP, you will see an isosceles triangle with base AB equal to 30 mm and this height is equal to 50 millimeter. So, let me draw the top and front views of the given lamina. So, I will mark a line AB representing the base of the lamina and this has got a length equal to 30 millimeter. So, I will just mark this as AB. Now, how to obtain this point C? Friends, here this length measured from this AB till this C is 50 mm. So, I will simply show by a very thin line and this measurement from the base to the C is 50 mm, 50 millimeter. Friends, this is the top view of the lamina when it is resting on HP on its complete surface. Now friends, when you look it in the front, from the front, it appears as a line. So friends, I project the line from here. So I draw a line here and again a line from this corner upwards. So we are going to get a horizontal line on XY, that is the front view of this lamina. So I will call this as A dash, B dash because both A and B lie on the same vertical line and this point is going to be the point C. I will call it as C dash. So friends, this is the top view of the lamina, which is an isosceles triangle with base 30 mm and height is equal to 50 millimeter and front view is a line on XY. And this line XY represents the line of intersection of HP and VP. Friends, for all these lamina problems on laminae, I am going to represent the so-called the width here as small m. It becomes easy when you redraw this figure in the second position. Friends, in this particular problem, this m is equal to 50, or it could be different in different problems. So always the front view of this I show by a length m, which can be measured from here to here. Friends, the lamina is resting on HP. On its surface, we have got the top view, an isosceles triangle, and front view, a line here. Friends, now he says it is seen as, or it appears as, an equilateral triangle of side 30 mm in top view. Friends, what happens? The side AB, which is on HP or parallel to HP, it will always remain the same. It won't change its length. Whereas when you slowly lift this up from this corner, what happens? The surface makes an angle with HP, and thereby these two sides AC and BC get reduced. So there is going to be only one particular value of that surface inclination with the HP when it becomes an equilateral triangle in the top view. So in the solution, he says it has to become an equilateral triangle. So obviously, you are going to get an equilateral triangle of side ABC with AB equal to BC equal to CA, each equal to 30 millimeter. So since the top view is given to be an equilateral triangle, I am going to write adjacent to this figure an equilateral triangle. This is our point A, this is point B, and here you know how to construct the equilateral triangle. This length is equal to 30 millimeter with B as center, radius equal to 30 mm. Draw an arc with A as center with the same radius. Draw another arc. These two arcs meet at this point C, and if you join A to C and C to B, this triangle ABC is the equilateral triangle of side is equal to 30 millimeter when this C is lifted upwards, keeping AB on HP. Friends, this is going to be the top view. Let me get the front view. So here, as in the previous case, you get point A dash, and this point is B dash, and C dash should lie somewhere along this line. So how to locate the point C? Friends, remember, in any of the problems on the planes or on the solids, whatever the length you have got this on xy will remain the same. The same length will be there, and even the measurement remain the same. That is to say, taking A dash B dash as center and radius equal to m, which is equal to 50 mm, I am going to strike an arc here to cut the vertical line drawn through C at this point. Say this is C dash. So I can join C dash to A dash B dash, and this will represent the front view of that lamina when it is inclined at an angle of theta to HP. So this angle theta is the inclination of the surface ABC with the HP, and this can be measured. Sometimes in the examination they ask you to find out what inclination the surface is making with the HP. Friends, you can see here the top view has become an equilateral triangle and front view is a line. Finally, in the question he says, draw its projections when the shorter edge is inclined at 30 degrees to VP. The shorter edge is AB, that AB was perpendicular to VP. Again, in this case, it is perpendicular to VP, and as per the question, we have to redraw this figure such that the side which is on HP, that is AB, should be at an angle of 30 degrees to VP. So friends, here I draw a line inclined at an angle of 30 degrees to VP and mark on this the side AB of length equal to 30 mm again. So this distance AB is 30 millimeter. This 30 millimeter I've drawn here. The point C can be marked either above AB or below AB. You get the same solution. So it is an equilateral triangle. I told you how to construct that. So I am going to construct this equilateral triangle here, and every side here measures 30 mm, and this point is C. Friends, remember very well, in all the problems on the laminae and also on the solids, this is figure number 1, this is figure number 2. Figure number 1 and 2 will always be same in all respect except its orientation. And if you call this as figure number 3 and this as figure number 4, the figure number 3 and figure number 4 are always identical. That is to say, they will have the same dimension. Friends, we have got the final top view of the lamina when the shorter edge is making an angle of 30 degrees. Now let's see how to obtain the front view corresponding to this top view. So let us go in order, start from the point A and end with C. Friends, here I write a vertical line from a horizontal line from A dash. The point where these two intersect is our point A dash. Likewise, B, you draw a vertical line from B, a horizontal line from this B dash. The point where those two intersect is the point B dash. Finally, we want C, write a vertical line from C, a horizontal line from C dash. The point where these two intersect will be the point C dash. So here we have got all the three corners of this lamina. We will join this by straight lines. So join A dash, B dash, B dash to C dash, C dash to A dash. Friend, this figure A dash, B dash, C dash will give you the final front view of the lamina corresponding to the top view ABC, wherein the side AB is inclined at an angle of 30 degrees with the vertical plane. Friends, I hope the presentation on this triangular lamina, which was an isosceles triangular lamina, and if you are really happy with the presentation I have made, please subscribe to my channel and share the information with all your friends. Thank you very much for watching the video.